I want to build a squirrel feeder and place it on my balcony. I thought, what if I wanted to build it on FreeCAD first? So here is the part where I model a squirrel feeder in FreeCAD. The feeder will primarily have three separate parts. First part is the home, where the squirrel will feel home while eating. The second part is a glass jar to store foods, and the third part is a support system for the entire thing. All three parts will be put together using some built-in interlocking mechanism. The home is 6 inches by 6 inches by 9 inches in dimension. I want the home to have a sloped roof to better handle raindrops. A 25 degrees slope should work fine. At this moment, I thought having the base cube centered will benefit me for the rest of the build. So here I am adjusting in Y direction. I will adjust the X direction in the next step. I have used this along edge feature of extruding quite a lot in this build. Keeps me from providing the dimensions every now and then. I am using the thickness tool of part workbench to create the shell of the home. A 4 mm inward thickness for the walls should be okay for now. Now I want to have 3 holes in the home for a squirrel to come in and have a choice about it. There will be 2 side doors for squirrels and another hole for the glass jar to fit in. I want to use cylinders from primitives in part workbench to make these holes. A 100 mm diameter cylinder should do for now. Placement of this cylinder is important, and this will determine where the holes will appear. While I'm at it, let's place another cylinder for the front hole. I want to have both of these cylinders unified, so I will have to make only one cut to make 3 holes. There they are. As I mentioned earlier, 2 side holes will give a chance to the squirrel to have a choice about which door he wants to use. In 2023, it's implied to provide choices to the consumer. Now let's put a roof on top of the home. This is the only time I mapped a sketch on a surface. Given it is inclined, mapping the sketch on a surface made more sense than doing a bunch of other things for the sake of best practices. For now, I am going for a 5 mm extrusion. I also wanted to have some spline on top of the roof. Given how small area of this roof is, splines may not make much of a difference. I wanted to have them anyway. These splines will give the room a corrugated metal roof kind of vibe. Sketches in this build took a lot of time, mainly because I have to come up with these dimensions out of thin air and do several trial and error before settling onto something. If I had a technical drawing, it would be much easier to build this model. Having said that, I don't want to bore you by watching me drawing something and deleting over and over again, although it is the part of sketching. So I will cut to the end of the sketch. If you are following to build this model for practice, maybe you can pause the video where it makes more sense to take the dimensions of the screen. If you need, I can also send the model to you via email if that makes easier for you. Thinking about how I want to use the support system and embed it in this part, I want to make a notch that will allow me to assemble the second part of the build with the part already modeled. So it will be a groove that will go through the wall of this home part. With that, here comes an interlocking mechanism not too uncommon in the real world. Having these separable connections in the model will also help to print this in a regular size 3D printer, one part at a time. Found that it's easy to mirror parts in part design when it comes to a different line of reference. For example, my mirror plane for this specific task is not on any standard XY, YZ or XZ plane. It's on XY plane at an offset from the origin. In part design, I could select that reference face directly. But here in part workbench, I will have to select XY plane and later update the offset distance. Weird, right? Here goes the interlocking mechanism I will be using later to key in the other part. Now let's get our hands on the glass jar. In practice, this is something will be acquired from a store. Definitely won't be anything 3D printed. So the dimensions of this glass jar as well as the diameter of the hole that we did in the first part will depend on the jar that I will buy from a store. Just keep in mind where to come back and update the sketch once the jar is at my hand. For now, I will go with something that looks good in my eyes. Using the revolve button, making the jar is pretty easy as long as I have the sketch drawn right. I intend to do some Blender rendering later on. I'll make it more realistic, but for now let's make it semi-transparent and call this a face. At the third and last part, I want to create a support system for this feeder. The support system itself is a two-parter. One support is dedicated to hold the glass jar up at its intended place. I want to make it look like a plate, which will be fitted into the interlocking mechanism I created in the first part. Keep in mind that this idea will be revised right before I decide to print it, after giving some more thought into this model. Sketching this took me a lot of time because of this interlocking system. I want to build 2 more interlocks embedded into the bottom part of this plate, just to make sure I will be able to key in the overall support that I will be modeling in the next phase. In the next video, I will present a sample FEM analysis of this model in a couple of days. These fillets and the interlocking systems presented a big challenge during the FEM analysis. But these are part of the model that is more important to have during FEM. So, just like a hard pill to swallow, cannot ignore them no matter how much I wanted to. As I am here updating the sketch for the jar support, I thought I could make the vertical slats drawn within this sketch and make it one piece. Now that the vertical slats are done, I want to make the jar fit right onto them. This cylinder will make sure a boolean cut will create the right place for the jar to sit on. I did not want to map this sketch on the existing model. That's why you saw me get an idea how far I wanted to offset the sketch of the sacrificial cylinder. As I said before, this dimension will be solely dependent on the jar I will get from the store. So a note to myself, look here twice and update the dimension before printing. Now let's get working on our final support system for the overall build. An overall support system for the feeder. What it is already built will be sufficient if I was going to place the feeder on a flat surface, but I intend to hang it on a wall. In a hanging situation, so to speak, the self weight of the glass jar support system will break down. To make this model a versatile design, I want to add a bottom support system that will allow it either sit flat or hang tight. I want to make a simple cross-braced truss system in place as the overall support. Sketching this won't be easy. I realized having another vertical member at the right end of the home portion would not be a bad idea. So here I stopped sketching, went back and make another copy of the interlocking mechanism and relocate it to the end of the home. With these at the bottom and the other two from the jar support plate, 4 interlocking mechanisms paired with a suitable truss. this model will be sturdy enough for definitely more than one squirrel. It's not going anywhere. I like this feature of part workbench the most, being able to reuse portion of a model without worrying too much about active body or a body in general. Part design is sensitive as far as body goes, but part workbench does not bother about a body at all. Keep all components floating in this space. If needed, there are Boolean operations. I can reuse any of these components at any time. Anyway, it took me a minute to finalize this sketch. There are a lot of lines with a lot of constraints to manually set, and it was a mess. I wonder if using more construction geometries in this truss sketch would make my life easier. Maybe it would. Next time I do something similar, I will try with construction geometries, a lot of those, and see if it makes a difference. Even after a fully constrained sketch, the extrusion didn't work first couple of times. I had to go back and update the sketch, make it a closed wire. I wish the extrusion would recalculate after this update in the sketch, but it does not. I have to delete the existing extrusion and extrude it again. Boring. If there is a different way to make this change in sketch reflected in an extrusion, please let me know. There it is, the support truss for the overall feeder. It's not the best design truss in the world, but it will do it for now. I want to make 2 more copies of these truss and place them at 2 ends. It is probably an overkill to have this truss used 3 times to support which may be 1 kilogram of weight the most. But let's do it anyway. In practice, these trusses will need some lateral bracing as well. That's the end of the modeling part of the feeder. 3 separate parts will be printed individually and assembled later on to make up this feeder. I intend to do an FEM analysis on this model in FreeCAD in the next video. I hope you liked it so far, and I will see you in the next one. Thanks for watching.